Hello and welcome. This talk is called Features of a Modern Terminal Emulator. Depending on your computing platform, there are a dizzying array of terminal emulators from which to choose. Which one will suit you best depends on which features and capabilities that you require. Terminals and terminal emulators have come a long way since their humble origins in the teletype, the VT100, and even the relatively modern Xterm. In this talk, we'll explore some of what I consider to be the more interesting capabilities and features offered by a modern terminal emulator. One feature that I believe helps define the modern terminal emulator is how they handle fonts. Let's kick off the fonts discussion with a brief overview of Unicode and UTF-8. In the old days, there was an assumption that a single character was exactly one 7-bit byte, and thus we were limited to 128 different characters, which worked pretty well in the US, but not so well in other countries. Unicode is an ISO standard that attempts to create a single unified character set for all the world's writing systems, both past and present. There are a number of different schemes used to encode Unicode, including UTF-8, which is backwards compatible with ASCII and became the default encoding scheme in mainstream Linux distributions sometime around 2002. If you were designing a font for a terminal back in the 1970s, your job wasn't that hard. The fonts were bitmapped, they were a fixed size, and you had to come up with only 95 different characters, because 33 ASCII characters were non-printable. Today, monospace fonts used in terminals routinely have thousands of different characters, also known as glyphs, that they can display. In the English-speaking world, you may be wondering why this is useful to you in a terminal, which brings me to the next section on the private use area. There are areas inside the vast Unicode space that are designated as private use, which means the standard doesn't define what kind of glyphs or characters go there, and you're free to fill it with whatever you like. In the terminal, folks often fill this first private use area of 6,400 code points from Unicode E1000 to E8FF with icons. Some of the icons shown here are sourced from various freely available icon fonts, like the Material Design icon set from Google, Octacons from GitHub, file icons from Sublime Text, and the Font Awesome fonts from the Bootstrap framework. These icons can look really nice inside your terminal-based text editor, and can be handy when navigating files and directories. I'm using GNU Emacs in this example, but you should be able to get similar results with Vim or NeoVim. I also have a patched version of ls from GNU Core Utils that emits private use area Unicode characters to enhance file listings. Pretty cool. The way this works is that I have a font called iconsintheterminal.ttf, which aggregates a bunch of these font icon sets into a single font and jams them all into the private use area. I configure my terminal emulator to use this font as a fallback whenever it can't find a given Unicode code point. Now, because all of the fonts I use, the private areas are empty. This will guarantee that the terminal will pull the glyph from the icons in the terminal font if it resides in the private use area. I'm using iTerm2 on macOS in this example, which lets you define a single fallback font, but other terminal programs like Kitty, which work under both macOS and Linux, give you even more control of how you manage fallbacks. In Kitty, with the symbol map directive, you can select a range of Unicode characters and then map those to a specific font, which is pretty great. Modern terminal emulators have features that help you make the most of OpenType fonts, which have a lot of really neat typographic features, some of which I'll briefly touch on now. The way ligatures are used in programming fonts like Fira code is that you take two or more characters like equals, which in many programming languages means not equals, and combine them in a single, more aesthetically pleasing glyph. The same thing works with double equals or triple equals and more. The next OpenType feature I'd like to touch on are stylistic sets. This allows you to make minor aesthetic tweaks to the font depending on your preferences. Maybe you like a 0 with a dot in the center rather than a slash. In Fira code, I don't particularly care for the way their @ and ampersand look. The designers probably thought others might agree with me, so they included a stylistic set or two that lets you change these defaults. The Kitty terminal program has some of the best font capabilities of any terminal program I know of. And of course, it lets you enable font features like specific stylistic sets with the Font Features directive. Let's add SSO3 and SSO5, which should fix the ampersand and @ for us. Next, let's talk about a set of ANSI escape sequences known as SGR for Select Graphics Rendition. These escape codes let you set some display attributes in the terminal which modify the look of your characters. It can render them in bold, italic, underline, strike-through, or all of them at once. A modern terminal will support these escape sequences and select the right font in your chosen font family to render the characters, or alternately let you choose which font you'd like to use for the various renditions. I've whipped up a little script that emits the various SGR escape sequences, which I use to test terminals to ensure that everything is working as I expect. Getting these escape sequences to work in most terminals isn't hard, but getting them to work with terminal multiplexers like Tmux or Screen, or on remote hosts over SSH can be quite a challenge. Perhaps a topic for another talk. Let's stop talking about fonts for a while, and let's talk about the mouse. In the 1970s and 80s, terminals didn't have mice, but in 1990, with the advent of the VT420, came something called the DEC locator mode, which defined a standard for reporting mouse coordinates to the terminal. Later, Xterm added some extensions which allowed for motion reporting, which we all enjoy today as Xterm mouse support. One very common use for Xterm mouse support is with terminal multiplexers, like Tmux or GNU Screen, which maintain their own history or scrollback buffer. I like to use my mouse scroll wheel to sort of absent-mindedly flip through my terminal history. It's also great for sizing and selecting windows, both in Tmux or perhaps a text editor. You can click around and select windows and then whip your scroll wheel back and forth to scroll up and down in various windows. It doesn't redraw as fast as a pure GUI application, but more and more terminals have GPU support. Perhaps we'll get there. The thing that blew me away about Xterm mouse support when I first discovered it was that it works over SSH. Here I'm going to SSH into Eidolon, a community host physically located in a data center where I read my email and talk on IRC. I probably shouldn't be, but I'm still kind of amazed that this even works. Another really great feature that I can't live without is known as the OSC52 escape sequences. These sequences allow you to interact with your operating system's clipboard. OSC stands for Operating System Command, and there are a number of these sequences that let your terminal perform various integrations with your OS. OSC52 in particular was invented by Xterm, and it allows terminal applications to read and write various X Windows clipboards. Many modern terminal emulators borrowed this feature from Xterm, and it's super useful from inside my text editor or in Tmux, where you can select some text with the mouse or keyboard and then just plop it into your OS clipboard. Next up, we're going to talk about bracketed paste mode, which is another feature that comes to us via Xterm. The way this works is when your program, like a shell or a text editor, emits a special escape sequence that signals your terminal that it wants to enter bracketed paste mode, and then from there on out, whenever you paste something into your terminal, it'll wrap it in escape sequences that let the program know that the inserted content was the result of a paste, rather than actually keyed in on the terminal. Let's say you accidentally paste some new line delimited content from a web page or somewhere else into your shell. Normally the shell will interpret those new lines as a signal to run whatever you just typed in, which can sometimes lead to a terrible mess. You can enable bracketed paste in your shell, I'm using Bash in this example, but it works with ZSH and other shells too. This will prevent the shell from executing any commands that are pasted into it. In Bash, it'll show you the pasted content and wait for you to press the Enter key if you really want to execute it. This is a fantastic safety feature that I think more people should know about. Next up, let's talk about colors. Early terminals didn't support any colors at all. They had monochrome displays. Later extensions added support for 8 colors. Well, actually 9 colors if you count the default color, which isn't part of the 8. They were traditionally black, red, green, yellow/orange, blue, purple, cyan, and white. Color 9 is the default. Later innovations gave us 16 colors, which used a bright attribute so that when bright was on, you got bright red instead of red. This allowed for a total of 18 colors, bright versions of the 0 through 7 colors, as well as a bright version of the default color, color 9. At some point, Xterm came up with a scheme for defining a 256 color palette that you could select from using escape sequences. This became known as Xterm 256 color, which up until recently was sort of the standard. Nowadays, modern terminals can support 24-bit color. That is using 3 8-bit values for each of the red, green, and blue components of the color. In theory, this lets you represent 16 million colors. Now, it's not like you're going to see 16 million colors at once in the terminal. There just simply aren't that many character cells, so you might think this is somewhat useless. What it is great at, though, is defining the exact shade of color you want to use. When designers make themes for GUI programs like text editors, they often do so using 24-bit color. In the terminal, where you're typically choosing the closest match from a fixed 256 color palette, this often comes out looking subtly wrong. If I run my text editor in the terminal without 24-bit color support, and then compare it against the GUI version on the left-hand side of the screen, you can see that the colors are subtly different. The background isn't the right shade of black, and the blue in the title just isn't quite right. You might not think this is a big deal, but with some color themes, subtle color differences are used to highlight things, which you might miss entirely if you didn't know what you were looking for. Notice when I switch back to the 24-bit color version, how the colors match exactly. It's the same font, but in the terminal I adjust the spacing between the letters so it doesn't look so monospace. This is another great OpenType font feature that modern terminal programs support. While 24-bit color support is great, it has some problems. For the longest time, there was a lot of disagreement on how it should work, how programs should detect if a terminal is capable of displaying 24-bit color, and if Xterm or the ncurses library would even support it at all. As a result, it's still a bit of a mess, and you might find it a bit of a challenge to convince your terminal applications like Tmux, Vim, Emacs, and others that your terminal actually is capable of 24-bit color operation. Your mileage may vary. For our final topic in this talk, we're going to talk a bit about graphics support. That is the ability to display images in the terminal. There are a couple of different applications for this that I think are interesting. The first of which is for file manager type programs that may want to show you a preview of a file. Let's say that you're organizing a directory of desktop wallpapers and you'd like to delete some of the ones you don't like. Popular TUI programs such as Ranger have the ability to do this. Secondly, you may want to see a graphical plot from a program that you're writing in an environment like a Jupyter Notebook, or from an interactive program like GNU Plot. I personally would like to be able to see embedded images in org mode documents inside the TUI version of GNU Emacs. This all sounds great, but there are problems. Graphics support in the terminal is unfortunately far from standardized. The closest thing we have to a standard is the SeaGL format, which originated from terminals and printers from DEC. SeaGL, which stands for 6 pixels, is a bitmap format where the images are encoded by a pattern that is 6 pixels tall and 1 pixel wide, which allows for 64 different patterns. Each pattern gets assigned an ASCII character. While this works and is supported by Xterm and iTerm 2, it's not very efficient and breaks down when viewing larger images. This has led to terminal program authors implementing their own incompatible systems for displaying images in the terminal. The iTerm 2 emulator uses a custom OSC 1337, get it? And expects base64 file encoded contents and supports a number of image file formats. Kitty uses its own format, which is called the Terminal Graphics Protocol, which is well described, seems well designed, and is said to be quite a bit more efficient than iTerm 2 system. Terminology is another terminal program which also has its own format. Besides the problem of there being way too many standards to choose from, popular terminal multiplexers like Tmux or GNU Screen don't support any of these at all, which for me is really a bit of a non-starter. Having said all that, let's see if we can do a little bit of a demo here. Let me drop out of Tmux. Let's see what I've got in my home directory. So if you just cap this file, I think I have a file called SeaGL.sixel, which there you go. This is iTerm 2 rendering SeaGL.sixel here right in my terminal. And that's how it's supposed to look. And that's pretty cool. Let me run Ranger real quick. And Ranger is configured here to use the iTerm 2 image format. That's how I have it set up. So if we go into my wallpapers directory, yeah, there we go. It's actually looking at these PNG files. This one is 9 megabytes, so it takes a little while. This one's a little bit smaller. Yeah, pretty cool. You can see how this would be sort of handy for, managing smaller images. It would be pretty cool. I still think this is neat, but because it doesn't work inside of Tmux, it's of really limited usefulness to me. Like, I live inside of Tmux, so I really need that support. Anyway, that is about the end of this demonstration. And I think we've got a little bit of time left over for questions, so if there are any questions, I will take them now.